Welcome. I am going to discuss chiral separation of neutral molecules using polysaccharide chiral stationary phase. This is third lecture of chiral separation series. In this session, you will learn which phase will be suitable for neutral molecules, what should be mobile phase selection procedure, how separation can be improved, what should be next step if separation is not achieved. Polysaccharide chiral stationary phase can be divided into cellulose ester derivative, cellulose carbamate derivative, amylose ester derivative, amylose carbamate derivative. Following columns are available in the market in both cellulose ester derivative and amylose carbamate derivative and highly used in all types of molecule, whether it is a polar or whether it is non-polar. Now question is, which column will be suitable for separation of neutral molecules? We are going to discuss in next slide. Cellulose ester phases are preferable choice for neutral molecules in both normal phase mode and reverse phase mode. This is the ester derivative phase. If separation is not achieved in this phase, means ester phase, then only other phase can be tried and we will discuss during case study. How to select mobile phase in normal phase chromatography mode? Preferable mobile phase is a mixture of alkane and alcohol. In place of alkane, generally hexane and heptane are used. In place of alcohol, generally ethanol and isopropyl alcohol are used. Composition of alkane is higher whereas alcohol is lower. No need to add modifier. Retention time is generally shorter with lower chain alcohol, for example, ethanol, than higher chain alcohol, for example, isopropyl alcohol. Similarly, retention time is shorter with lower chain alkane, for example, hexane, compared to higher chain alkane, for example, heptane. Start the development taking mobile phase as a mixture of hexane and ethanol in a ratio of 75-25. Suppose you are getting two peaks but there is not baseline separation. In that case, ratio of ethanol can be reduced from 25 to 20 if required, then 15 to get baseline separation of the isomer peaks. Definitely there will be baseline separation. If more separation is required, then temperature can be reduced, injection volume can be reduced, flow rate can be reduced. If required, in that case, isopropyl alcohol can be used in place of ethanol and same fine tuning will be made as it was made with the ethanol. Definitely separation will take place. If required, column dimension can be increased. Column with lower particle size can also be tried. Coming to case study. This is the molecule. Now question is, what should be a stationary phase? Definitely ester phase is more suitable. Here, what should be mobile phase? Take hexane and ethanol as discussed in the previous slide in ratio of 75-25. do the fine tuning, definitely you will get the separation. Now see in which condition both isomer of these molecules are getting separated. Column ester derivative, mobile phase, heptane, ethanol in ratio of 90:8, fluoride 0.5. In this condition, see how peak is visible. Both peaks are getting separated and there is base to base separation. Now another case study 2. See the molecules. This is the non-polar molecules. There is not any functional group which can make the hydrogen bonding. Here same stationary phase, that is cellulose ester derivative, can be used. Take the mobile phase, mixture of hexane and ethanol. If both isomer of these molecules are getting separated, fine. Otherwise, replace with isopropyl alcohol. Make the fine tuning for better separation. Now see which condition both isomers of these molecules are getting separated. Column chiral OJH, mobile phase, heptane, isopropyl alcohol in a ratio of 85:15. Both isomers of these molecules are getting separated. There is baseline separation. Mobile phase selection in RTC mode means reverse phase chromatography mode. For hydrophobic or non-polar molecules, mixture of water and organic solvent can be used as mobile phase. Generally, acetonitrile is preferable organic solvent, but isopropyl alcohol, methanol, or ethanol can also be added to improve separation. Alcohol masks the chiral selectivity of the stationary phase, and that is the reason alcohol is not used in the mobile phase. But in special cases, alcohol can be added in a lower quantity. For hydrophobic amine, use 10 to 20 millimolar of ammonium acetate or phosphate buffer with pH less than or equal to 4.5 as a base solvent, and acetonitrile as a modifier can be tried. Start trial with mobile phase composition, water acetonitrile in ratio of 60:40. Make adjustment with pH and concentration of buffer if required. Coming to case study, this is the hydrophobic amine. It has two chiral center, then 2 to the power 2, 4 isomers are possible. Now task is to how 4 isomer will be separated. A stationary phase, ester derivative phase is preferable choice. Mobile phase, take buffer with pH less than or equal to 4.5. Either one can take phosphate buffer or acetate buffer can be used. Acetonitrile can be taken as a organic solvent. For increase the separation, one can decrease the ratio of acetonitrile or decrease the injection volume or decrease the column temperature. Now see in which condition all 4 isomers of this hydrophobic amine is getting separated. In this chromatographic condition, all the 4 isomers of this hydrophobic amines are getting separated. There is a baseline separation of each isomer between each isomer. Second case study. This is also neutral molecules. A stationary phase will be ester derivative phase, mobile phase. Simply, one can take mixture of water and acetonitrile for better separation. Ratio of acetonitrile can be decreased, or injection volume can be decreased, or column can be decreased. Now see in which condition both isomer of this molecule is getting separated. In this chromatographic condition, using water and acetonitrile and ester derivative phase as a stationary phase, very good separation between both isomer of this molecule. This is all about chiral separation of neutral molecules. If you are new on this channel, please subscribe to this channel. Thank you very much for watching this lecture.